Hello everyone, this is Bhavesh, currently working as a cybersecurity intern at CyberSapiens. Today I am here to discuss about race conditions vulnerability, and we are going to discuss deeply about how this vulnerability works, what are its variations, what are its types and its impact, and we are also going to discuss the methods to prevent this vulnerability. So first of all, what is race condition? Race conditions are basically a type of business logic flaw when a web application is sent multiple requests concurrently, and the web application is not able to handle those requests properly. This vulnerability arises. So when endpoint gets multiple requests at the same time, which causes the data to collide with each other, and it causes unintended behavior in the web application. So the race condition attack is when an attacker carefully times those requests to exploit the unintended behavior for malicious purposes. Now, why is it important to understand race conditions? It becomes important because this vulnerability can lead to data inconsistency, and it can also allow any attacker to modify data without proper authorization. It also poses serious security risk, as attacker may exploit timing issues uh, to manipulate data and access unauthorized data. And unhandled race condition can cause the application to crash, and it can also be used to perform DOS attack, denial of service attack, on a web application, which can result in the loss of data and loss of resources for web application and the organization. So how race conditions occur? Let's take an example of an online store uh, where you can enter a promotional code for a discount on your order. So when you enter the discount coupon, the application transitions through a substate. In this state, the web application is in the processing, and it is in a state, and it processes the coupon, and in this state it is vulnerable to any other request. So if a user which has not applied that discount code before try to apply it twice at almost exactly the same time, the substate lets the code request in the substate, and it processes both requests at the same time, and when the substate ends, the discount coupon is applied twice, so the discount is also applied twice. Now, what are the variations of exploitation for this vulnerability? First of all, as we've seen in previous example, gift card or discount coupons can be redeemed multiple times. It can also be used to rate bomb or rate a product multiple times from same user account, which can be used for scams. And it can also be exploited when we are withdrawing or transferring cash in from one bank to another, or from one account to another. It can also be used to bypass the captcha and perform brute force attacks and bypass the rate limit functionality. So there are majorly two types of race conditions: single endpoint race condition and multi endpoint race condition. Single endpoint race condition, when we send parallel request with different values to a single endpoint and trigger a race condition, it is called single endpoint race condition. For example, let's consider a password reset mechanism which stores the user ID and reset token in the user session. Now, sending two parallel password reset requests from the same session but with two different usernames could potentially cause this collision, where the reset token of the victim is sent to the email address of the hacker. So this is single endpoint race condition. And next is multi endpoint race condition. It involves sending requests to multiple endpoints at the same time. For example, while shopping on an online store, when you add an item to your cart and then you confirm the order and move on to payment interface, but during the payment validation, the application might be entering into a substate where it is vulnerable and accept a new request. In this case, we can potentially add more items to the basket during the race window between when the payment is validated and when the order is finally confirmed. And in this interval, we can send a request for new product to the web application and it will accept those product, but it will not be added to the final cart value. So this is an example of multi-endpoint race condition. Now, what are the impacts of this vulnerability? The overall impact of race condition can vary greatly when affecting various programs and application, because most modern programs and application rely on multi-threaded processing to execute many actions at once. By exploiting race condition in user registration functionality, an attacker can get admin privileges, and other possibilities include manipulating API calls, tricking central server into executing same action multiple times, and a program can it is also used to make a program crash or perform a DOS, denial of service attack, and also can be used to generate errors and gain more information about the backend services. Now let's look uh, about the case studies which have happened in the real world. Uh, Most recent being GitHub. Last year, a race condition vulnerability was present in the GitHub Enterprise server, which allowed an outside collaborator to be added while a repository being transferred. This vulnerability affected all the versions of GitHub Enterprise Service since 3.8 version. And PayPal in 2005, there was a race condition vulnerability present in PayPal where the attacker can change the value of transaction after the PayPal account holder had initiated the payment but before the transaction was completed. So it was a very big impact vulnerability. It was also present in Wireshark in 2016. Wireshark is a widely used network protocol analyzer. It had a race condition vulnerability in its SMB dissector. Uh, in this vulnerability, an attacker could exploit and cause a denial of service condition and potentially execute arbitrary code on the user system, which was also very serious impact. So now how can we prevent this vulnerability? First of all, we have to ensure that our session handling frameworks keep sessions internally consistent. We should also utilize tools designed for analyzing and identifying concurrency issues. Static analysis tools, dynamic analysis tools, and code profilers can help detect potential race conditions. We should also conduct thorough testing, especially in the multi-threaded applications. Automated testing, stress testing, and scenario-based testing can help uncover potential race conditions. Mixing of data should also be avoided from different storage places. Thank you. Now let's see a practical demonstration of this vulnerability. So we'll use the Portswigger Academy lab for this demonstration. So this is the lab, limit overrun race condition. This lab this lab's purchasing flow contains a race condition that enables you to purchase item for an unintended price. To solve the lab, successfully purchase this item. We also have an account setup and its credential. So first of all, we'll start our burp suit and change the proxy, and we'll access this lab. So this is the environment. It is made like a online store. So first let's log in into the account which was given to us. Now we already have a credit, and we also have a promo. So let's add an item to our cart and use this promo. It has been added to our cart. So this is our cart, this is the product, and we'll apply this promo code. So as you can see, this is giving us a 20% discount on this product, and we still have to pay this amount. So let's check the burp suit. How is this working? There is a post request for coupon application, and after that the cart is being updated. So there might be a potential race condition vulnerability here. So let's try to apply this promo code twice at the same time. So first we will send this request to the repeater, and again we'll send it to the repeater, so that we have two requests to send. And we have these two requests. So first we have to remove this promo code, as we won't be able to apply it twice. So the promo code has been removed. Now we'll send these requests at the same time. So for that we have to add them in a group. Now we have to choose this option, send a group in parallel single packet attack, and we'll send this. The coupon is applied, so let's see how much it is applied. As you can see, the amount of the discount has been doubled, and it has been deducted from the final price, and it has reduced from 1000 to 855. So this confirms that this this web application does have race condition vulnerability, and we can use it to purchase this item for a negligible amount. So for that, first we will have to remove this, as we have a store credit of 50, so we have to apply it that many times. So let's add them. Let's add this request for 20 times, because 20% will be decreased after every final amount. Now as we can see, this group has 20 requests, and we are going to send them at the same time, and then we'll see what happens. So we have removed the promo code. Now we'll send them at the same time. Okay, so coupon has been applied. Let's reload the page. It has been applied, but it's still more than the store credit. So there can be sometimes that some request may not be accepted, because there is a very small window, and in that window it may be possible that some requests were not be able to send at the same time. So we'll have to perform this attack multiple times to get all the requests accepted at the same time. So we'll have to do it multiple times, and we'll remove this and try again. We can also increase the number and do it again. The coupon has been applied. Yeah, so the discount amount has become 1300, and the final price has become 15. So we can purchase this item, and we'll place order, and the lab has been solved. So this is how a race condition vulnerability can be exploited. This is only one way, and it can be exploited in many ways, and it can cause a greater impact than this. So thank you.